Number 4 on the 2015 exam. I thought this was an interesting one that might stump some students, especially the ones that aren't able to critically think. So hopefully you study how to think through this one, at least or you can understand how I think through this one so that you can maybe try on a similar one in the future, okay? Most of them are straightforward, but part D is the one that might throw people off, okay? Consider the differential equation dy dx is 2x minus y. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. Okay, so I didn't sketch it yet, but I pre-solved most of this. So most people already get intimidated, or not most people, a lot of students that I've worked with at least get intimidated because they don't like sketching slope fields, but it's not bad at all. There's only 6 points. So I just did a table of values. I don't think you need to show all this, but I want to know what the slopes are. So these are the 6 points marked, okay? So we want the slope, or dy dx, at those points. So for example, when x is 0, y is minus 1, that's this point down here. The slope, if we plug it in, is 1. So let's draw a slope of 1 right here, something like that, okay? The next point, it would be a slope of minus 1, this point. So let's draw a negative slope. And up here, it would be a slope of minus 2. So let's draw it a little steeper. So something like that, I don't know, okay? Steeper. All right, now over here, this point is 3 dy dx, so let's draw it quite steep, okay? The next one is 1, so let's draw it that, kind of matching this one. And then this one is the slope of 0, so let's draw a flat line, okay? Good enough sketch. All right, that's how we do that one. Part B, find the second derivative in terms of x and y. Determine the concavity of all solution curves for the differential equation in quadrant 1. Give a reason for your answer. Actually, this might stump some people too. The ones that aren't able to critically think because they just follow a procedure. Like this is a procedure thing. And this, you got to think for yourself because it's not a typical question that you get often asked on exams and all that. Okay, so some people will get stumped by that. Warning. So we got to be able to understand the concepts and critically think, not just follow procedures, because anyone can do that. In this world, even AI can follow procedures, like really routine procedures, better than we can, because we make mistakes. Computers, after they learn and train, they are much less likely to make mistakes. Anyway, so let's find the second derivative. We got to differentiate this. That's just 2 minus dy dx, okay? And what is dy dx? That's right there. So if we plug that in, this is technically fine. We can box that here, or we can box this one right here. We can just distribute the minus sign, okay? Now, what happens in quadrant 2? It's probably simpler than most people think. Okay, so in quadrant 2, that's up here, right? X is negative, y is positive. So let's look at what happens to the second derivative. X is negative in quadrant 2. So this becomes a plus something. Y is positive. So this becomes 2 plus something plus something. So the second derivative is always positive. So it's always concave up in quadrant 2. Okay? As simple as that. See? You just had to be able to think through it. And the thought process was quite simple. We just had to know that x is negative, y is positive. Then this would turn into plus something. This remains as plus something. Something positive plus something positive plus something positive is all positive, so concave up. As simple as that. No need to overthink. Of course, we have to be able to think it through, and this is not a specific procedure that you often do, probably. So we have to understand the concepts and all that. All right? Let y equals f of x be a particular solution to the differential equation with initial condition f of 2 is 3. Does f have a relative min, max, or neither at x is equal to 2? Justify your answer. This is very similar to the one I filmed right before. I think it was 2016, number 4b. Okay? So we have to use the concept that if there is a max min, the first derivative must be 0. Okay? And it must change sign, but at the bare minimum, it has to be 0. So we find the derivative at the point 2, 3. We find dy dx at 2, 3. Okay? So we plug in 2, 3 here. We get 1, which is not equal to 0. So there's neither relative min or relative max because the first derivative is not 0. That's your justification. As simple as that. Okay? That one's a pretty standard problem, so I wouldn't say that would stump a lot of people if they practiced enough and they got the procedure down, but let's go through this one. Find the values of constants m and b for which y equals mx plus b is a solution to the differential equation. How in the world do we approach this? If you took a differential equation class before, you probably finished with AP Calc BC. You can solve this using a linear equation or something like that, probably. Or it is a linear equation. But you don't know that technique in AP Calc BC, at least as with the filming of this video. So, how in the world do we find m and b? We get stuck. Or are we stuck? What is the solution to a differential equation? This is the key phrase here. That means this satisfies this equation here. That's number one that we have to, this first concept we need to understand. A solution to the differential equation means if we plug in this equation into this differential equation, the equality should be true. Okay? Concept number one. So let's start doing that. So what is dy dx of a linear line that's slope m? Okay? So m is equal to 2x minus y, and y is equal to mx plus b. So we plug everything in. Dy dx is m, as I was saying, which is equal to 2x minus mx plus b. Okay, so let's distribute this minus sign. Okay? Now what do we do from here? Let's ignore that first. How in the world do we find m and b? We need a system of equations, two unknowns, right? Or, as we're not given any more information, this is a technique that you might have seen in partial fraction decomposition. Instead of plugging in nice numbers to get your partial fraction decomposition coefficients, you can do the matched coefficient method, I call it. If I've never seen that before, I would recommend you watch my crash course in partial fraction decomposition video where I talk about this. This is probably online in a lot of places as well. We can match coefficients because, if I factor out x in the first two terms, okay? Something x minus b is equal to something x plus m. So there must be a something x over here for this equation to hold true, to be true. Something x plus something equals something x plus something, technically, okay? Since 2 minus m times x is over here, there's technically a 0x over here, okay? So 0x is equal to 2 minus m times x, which means that 0 is equal to 2 minus m, which means that m is equal to 2, okay? That's why it was matching coefficients. There's technically a 0x plus m over here, okay? So this 0x has to match this something x. And therefore, these constants, m must be equal to minus b. And since we know what m is, b is equal to negative 2, and that's the answer. All right? Again, this is probably something you have not seen before, and an average student that only follows procedures, knows how to follow procedures, would get totally stumped on this. You have to understand the concept of what is a solution to a differential equation, first of all, because you don't know how to solve this differential equation. You can't separate variables here. At least to my knowledge. You have to use the linear equation method, which you don't know in this class. So you got to approach it in a different way. So you have to understand what that means. And then we applied it, and then we solved the equation for m and b. And hopefully you've seen this technique before in partial fraction decomposition. All right? Okay, that's it for this video. Hopefully it was helpful. Again, lots of concepts here that we have to understand in order for us to get all the points here. Otherwise, you can't really just follow a procedure and get most of the points in this one, at least in my opinion, all right? Please give this video a like if you found it helpful, and hopefully I'll see you in another video as well. Bye.